Today we'll be covering halogenation of alkenes. The typical reaction utilizes an alkene with either bromine, iodine, or chlorine. Fluorine is not included due to it being too small and not polarizable. And moving forward, there are a couple other possibilities for this reaction that cause confusion for students, so it's important that we expose the other possibilities. Halogens do not appear to have an electrophile, but bromine, chlorine, and iodine are polarizable, and with a nucleophilic alkene, we can induce a dipole. The nucleophilic alkene will donate its electrons to the bromine, causing a repulsion of the negative charges and push the bromine's electrons towards one end, inducing an electrophile and a nucleophile. As you can see, this would create a carbocation. To avoid this, cyclization occurs and all atoms will have full octets, which is more stable than a carbocation. So this mechanism proceeds through a three-membered ring with one of our halogens incorporated in, and thus with a positive charge, such as a cyclic brominium ion, as we have here. This reaction will now proceed similarly to opening epoxides in acidic medium. Our nucleophile, the bromide here, will now attack the more substituted carbon of the cyclic ring. However, right here, we don't have a more substituted carbon, so both sides are equally possible for our nucleophile, or the bromide, to attack. This is a backside attack, so our nucleophile will end with the opposite stereochemistry as our cyclic brominium ion. And because that bromide can attack either carbon if there's not a more substituted carbon, and that cyclic brominium ion can form such that it's facing towards us or away from us, we need to be aware of enantiomers and diastereomers forming. Now we'll discuss nucleophilic competition with this reaction. So this reaction is going to proceed normally, as we have just discussed, forming that cyclic brominium ion. But because we have ethanol, this will outcompete the bromide as the preferred nucleophile for attacking the cyclic brominium ion, and will then attack the more substituted carbon. But similarly to before, we don't have a more substituted carbon, so it can attack either of those carbons. So the takeaway point is, if we have another nucleophile in the presence of this reaction, it will outcompete that bromide ion for addition. So what if we have two different halogens? How do we tell which one's the nucleophile and which one's the electrophile? Well, it's pretty easy. Whichever one's more electronegative will be the nucleophile. So the chlorine is more electronegative than the bromine. So that chloride ion will be the nucleophile and will attack at the more substituted carbon of our cyclic brominium ion. Pause now if you'd like to try this one on your own.